Scientists Gordon Hamilton and Lee Stearns are getting ready for a trip to the Helheim Glacier in East Greenland. These glaciers are a remnant of the vast ice sheets that covered much of North America during the last ice age. They allow us to travel backward in time to see what the Adirondacks might have looked like 14,000 years ago. What's happening to the glaciers right now also gives us a glimpse into the future. Gordon and Lee have been monitoring the activity of this glacier and others like it for several years.
There you go.
What we're doing on this glacier is we're installing GPS sites, so GPS measures your exact position on the planet. And we're putting in very high resolution GPS, so that it's recording every 5 seconds and giving you a precise position every 5 seconds. And what we're interested in is how fast the ice is flowing.
As this 36-hour time-lapse sequence makes clear, the glacier is moving.
Yeah, well, you hear the phrase, things moving at a glacial pace, but this doesn't apply to the glacier we're on right now. It's one of the fastest moving glaciers in the world. This one is being clocked at about 9 miles per year, that's very fast for a geological feature.
It's not just that the glacier is moving so quickly. It's the acceleration that's alarming. The speed of the glacier has tripled in just 4 years.
We reprocessed the data maybe 5 or 6 times just to make sure it was correct, because it seemed so surprising to us that a glacier can undergo such dramatic changes so quickly.
Unlike during the Ice Age, these glaciers are not growing. They're sliding toward the sea. All over the frozen world, scientists are drilling ice cores, time capsules that help explain why. Tiny bubbles of air trapped in the ice cores provide a record of climate change, some going back 800,000 years. These cores tell us that right now, the concentration of carbon dioxide and other gases that warm the planet is increasing faster than at any time ever documented.
If you look around on the surface here, especially in the middle of the day, you'll see a lot of meltwater being generated. The surface will look very wet, and that water collects in the crevasses that you see around us. Water eventually reaches the bed of the glacier, which is about 3,000 feet thick in this place. When it reaches the bed of the glacier, it acts as a lubricating layer, and it allows the ice to slide faster over the rock. And what we think happened is that beginning with this climate warming, this extra meltwater was generated on the surface, and it's reaching the bed much faster, allowing the glacier to move at much faster speeds.
At the glacier's front, chunks of ice break off into the fjord and float out to sea. These newly formed icebergs raise sea levels around the world. If the current warming continues, sea levels will rise, perhaps by as much as several feet by the end of the century. With 1 out of every 10 humans on Earth living in low coastal areas, this would be devastating.
We want to just get across that a little bit of a temperature change can cause a lot of systems and Earth processes to change.
And it's the speed of these changes that cause some alarm, because we don't know these changes are going to occur until we've observed them, like we did here in Helheim Glacier. And who knows what other changes are out there waiting to surprise us in the coming years ahead.